Okay, what we're going to do now is I just want to briefly introduce or reintroduce what you should be already familiar with, but I want to say hello to my friends at Ocean. Frank, great guy, a wonderful chiropractor, wonderful, could crack any back. Frank, you might be interested to know that I found out that almost my entire thoracic section is fused. Pretty amazing. Hello, Rookie, the Rookie. How you doing, Rookie? I hear you're dating John. Is that true? No, just kidding. Anyway, and also Krista. I have some chemistry videos that you could look at. You might let me know what you think. I'm not suggesting you might want to use them. They're probably way beneath your standard, but I'd certainly like to see. I'd certainly like to know what you think. When I was supervisor, I kind of stole her from another school, sort of. It was great. It was wonderful. What a great addition to the staff. And then there's my wife, okay, who always cooked for me, who's at the school. Hello, wife, Christina. I'm just kidding. She's not my wife. She would always bring in food for me. Like, we'd have lunch. I hated to cook. She would always cook. It was great food. I missed that. And I hope that's everybody. I think that was everybody. And then there's John Gara. Oop, I said the last name. That's okay. And he is Mr. Excitement. Okay. This guy has his doctorate in engineering. It's amazing. One of the brightest guys I know. Unbelievable. And I don't know if John was there, but whatever. Anyway, hello everybody. Anyway, let's do a quick problem. What is it now? It's Skye. Skye is trying to get her dog out of the house. Help me out here. Is it horizontal? Horizontal, right? And so there's this dog. What kind of dog is it? Does anybody have the paper with them? Is this it? Right here? Okay, so it says Skye is trying to make her 70-kilogram St. Bernard. So this is 70 kilograms. 70-kilogram St. Bernard out of the house, right? And then, and we know, what do we know right away? What force do we know? We have 70 kilograms, so what force do we know? We know this force. You want to draw John would always tell me, draw what kind of diagram is it? You want to draw a diagram with all of the forces. FW, what's FW? The weight, right? Isn't FW the weight? Okay, FW is the weight. And we know the weight equals mg. So FW will equal what? What's FW? That's right, 700 newtons. So if it's horizontal, what is equal and opposite to the FW? They're thinking. Omar? Mohammed? Amir? I call Amir the bear. He's the bear. How do you say it in Indian, like big bear? How do you say that?
Badagoli.
Bada?
Badagoli.
Badagoli. Badagoli. Big bear. Yeah, he's big bear. He's the only bear I know that wears black rimmed glasses. Okay? He just came in from salmon hunting at the airport. Excellent. Okay, so what is it? Fn, right? That's right, Fn. And that's going to be 700 newtons. Okay? Now remember, if it's horizontal, Fn and Fw are the same, correct?
Yeah.
Yes? Now, do they give you anything else in the problem? What do they give you?
Friction.
They give you the friction, the coefficient of friction. The coefficient of friction is recognized by the Greek letter lowercase. Anybody know what this is? It's mu. Looks like a U or a fancy M with a front tail, however you want to say it. It's a mu, okay? And that's going to be, what is it, 0.5? 0.5. Right? 0.5. And you know the equation from your equation sheet, Omar. What does the coefficient of friction equal?
The weight over.
The what? What two things? The coefficient of friction equals what? Equals the force of friction divided by what? The normal. Okay? Now, so far so good? Now, what else does it give you in the problem? All right, so Skye is trying to get her 70 kilogram St. Bernard to go out the back door, but the dog refuses to walk. If the coefficient of sliding friction between the dog and the floor is 0.5, how hard must Skye push in order to move the dog with a constant speed? So in other words, let's say I want to push this. It's going to be FP. I want to push that vector, okay? That's going to be the vector that, because we're going to go this way at a constant speed, okay? Right? Constant velocity, right? And so that is going to be, you got to attach the vector, right? Professor Garrett told me the vector has to be on the object, correct? Yes? And so which direction is going to be the force of friction? If I'm pushing the St. Bernard out the door, it's going opposite to this, right? Okay, so it's going to be going like this way, and it's got to be the same length as it's going to be. Why has it got to be the same length? I kind of gave the problem away a little bit. You know, it's 8:30 in the morning in Abu Dhabi. It's cloudy. We're having very minor sandstorms, and everybody kind of looks like, bah. You look stunned, okay? Like Omar's looking at me. When I used to be an EMT and there'd be somebody dead, they looked just like that. This is how they looked. You ready? This is how they looked. You ready? That's how they looked. You ready? You ready? You want to do that again? I'm imitating a dead person. You ready? This is how Omar looks at me right now. You ready? Do you see a similarity? Okay. Now, so why does the F friction have to be the same as what you're pulling? Why does it have to be the same?
The equal opposite.
They're going to be equal and opposite, but what happens if there's a net force? If there's a net force, what happens to the dog? The dog will, it starts with an A.
Accelerate.
Yeah, the dog will accelerate. So if there's a net force, if I push harder than the friction allows, then there will be a net force, correct? And the dog will unceremoniously accelerate out the door. Yes? You get it? So they've got to be equal and opposite, correct? Yes? So by finding out FF, I know what FP is. I know what Fn is because that's the same as Fw. So if this mu equals 0.5, then 0.5 equals what? FF over F what? Fn, right? So if I replace Fn with what? Do it mentally. If I replace Fn with what?
0.5.
Fn, it's right on the board.
700.
The guy from Lithuania said Fn is 0.5.
700. Okay, yeah.
Minus 5 points for Gryffindor. Okay? All right, you got that? All right. So you're going to replace it with 700. So 700 times 0.5 is? Is what? 350 newtons. So what does it ask for? What is the actual answer? I mean, what are they asking for? Read the problem. How hard she has to push, correct? If it asked you for what is going to be the force of friction that she will encounter to push it at a constant velocity, would it be a different answer? They're thinking. I like that. They don't look stunned. Omar actually blinked. I like that. Omar, what would the answer be any different? Let me ask my star child, Kennedy. Would the answer be any different? Yeah. It's early, I know. No, the answer would be the same, because the force of friction and the push force or pull force has to be the same, because it's a constant velocity. So if you're pushing the dog, you're finding what? You're finding the push force indirectly by finding the friction, and then what are you doing? You are analyzing you ready? Dr. Gary, you're going to be very proud of me. A free body diagram. And you're going to say, well, let's look at the free body diagram. Well, that vector equals that vector. This vector equals 350 newtons. So that vector must equal 350 newtons. Why? Because it's a constant velocity. Clearer? Clearer? We're off. Just a word for the rookie, okay? You got to learn how to do lesson plans and teach, okay? I know that you're working at it, but she's still a rookie, okay? I'm teasing. She's actually a very good teacher, but don't tell her that. Oh, I just did. Okay, have a good day. See you later.